Welcome to this video. So in today's video, we are going to be looking at questions from Tutor Sheet 5. So questions from Tutor Sheet 5 are on acid and base titrations, okay? There's also a question on back titration, and there are also questions on oxidation numbers, okay? So that's what we're going to be doing in this video. So let's start solving question 1 there. Okay, so question 1, they're saying a 4.9 grams pure sulfuric acid was dissolved in water. The total resulting volume was 200 cubic centimeters. Then 20.7 milliliters of this solution was titrated with 10 mils of sodium hydroxide solution. Okay, calculate the mass of sodium hydroxide in the 10 mils of the sodium hydroxide. And then they have even given us the chemical equation there. Okay, so to make this question easier for us, I'm going to draw a picture of what is happening. Okay, so they said, first of all, they have 4.9 grams of pure sulfuric acid. So if this is in mass form, then it must be solid form. So it's like a powder. So we're going to say, okay, let this thing here be powder, and let this thing be what? Sulfuric acid. Okay, so this is my sulfuric acid, which has a mass of 4.9 grams. Okay, and then they said they mixed this, okay, with water. So I have some water there. Okay, so this is water in blue. Okay, so they mixed, okay, or they dissolved this powder into this water, okay, and they formed a solution that had a volume of 200 cubic meters, okay. So this is the resulting solution here, okay. So the sulfuric acid and the water, they combine, they form one thing. So let us indicate it like that, and then we also have the water there. So like the sulfuric acid has dissolved in water, right? And the volume that it has formed up to here, they're saying it's what? 200 cubic centimeters. Okay, and then thereafter, 20.7 mils of this solution, okay, it was titrated with 10 mils of sodium hydroxide. So from this 200, okay, they get um, just 20.7 mils of it. So 20.7 mils of it can be somewhere there. So from this 200 that we have, okay, they just get like a 20.7, okay, milliliters. So we have to know that cubic centimeters is the same as the milliliters, okay? All right, so you've seen that we had this mixture of the sulfuric acid and water giving us this volume, okay? And then afterwards, from this volume of 200 cubic centimeters, they just get a volume of what? 20.7 mils. Okay. And then this 20.7 mils now reacts. Okay. It reacts with the base because this is still sulfuric acid here. So this guy now reacts with the base. Okay. And this base is sodium hydroxide solution. And they're saying we have 10 mils of it. So this is our sodium. Okay, so I have 10 mils of it. So now they react this thing, which is 20.7 of the sulfuric acid, with 10 mils of the what? Of the hydrochloric, I mean the sodium hydroxide. So what do they form here? They form a solution together. Okay, so 20.7 plus the 10, that will go up to like 37 somewhere there. Okay, so this is the mixture of the sulfuric acid now and the what? And the sodium hydroxide. So this is the mixture here. So this is the reaction that is happening between this sodium hydroxide, which is here and there. So they mix them, they form this. Okay, so this is the reaction that is happening here, and it's been indicated by this what? This reaction. So the question here, they're saying calculate the mass of the sodium hydroxide. So we want to calculate the mass of this guy. So how can we calculate the mass of this guy? Okay, we'll use the mole ratio to the sulfuric acid, because the sulfuric acid, we have enough information about it. Okay, we have the volume, we have the mass, so we can use to calculate the what? We can use that to come up with the moles of the of the sulfuric acid. And then once we have the moles, we can get the mole ratio with the sodium hydroxide. Okay. And then from the mole ratio, we can be able to come up with the moles of this, and then just combine that with the molar mass to get the what? The mass of this sodium hydroxide. Okay. So first of all, we're going to find the moles of sulfuric acid that are in here. Okay, we're going to find the moles of sulfuric acid that are in here. So how do we do that? Okay, so we have been given the mass there, the one that has dissolved here, which was this guy. Okay, it was 4.9 grams. Okay, so how do we calculate the moles? We know that moles is just equals to mass over what? The molar mass. So what is the molar mass of this sulfuric acid? Okay, so sulfuric acid is H2SO4. So we just go on the periodic table, we get the molar mass of hydrogen, multiply it by 2, okay, and then add the molar mass of sulfur, and then add the molar mass of 4 times the what? Oxygen. So when you do this, okay, just go on your periodic table, you add this molar mass, you're going to get approximately 98.08 grams per mole. So this is the molar mass of sulfuric acid, okay? So if I have the mass there, 4.9, I can divide it by the molar mass, which is 98.08 grams, okay? So for those who do not know where this is coming from, just go on your periodic table, okay? Do 2 multiplied by the molar mass of hydrogen plus the molar mass of sulfur plus 4 multiplied by the molar mass of oxygen. You're going to get this number. Okay, so let's divide this now. So we have 4.9 divided by 98.08. Okay, so when I divide that, I'm getting these moles. Okay, 0.049959216 moles. So these here are the moles, okay, that are dissolved in that water to make this volume of what? 200. So in this green jar here that we drew, we have these moles of what? Sulfuric acid. Okay. All right. And then now they're saying from this volume that had which is 200, okay? It has these moles. They just got a volume of 20 plus 7 moles, okay? So if you are diluting, the moles don't change. But here we're not diluting. We're just getting a part of this solution and putting it in another jar. So the moles there will change because the mass of this whole thing will change. So if the mass changes, we know that mass is involved in the calculation of the moles. So it means the moles that are here, okay, are not equal to this, okay? These moles here are in this jar. So if we just get a part of this solution, it means even the moles will change. So how do we find the moles that will be here? Okay, so here we can write this number on top of this green jar. So 0.0499592 okay, moles. Okay, so these are the moles that are here. So how do we find the moles that are here? We just use the ratio. Okay, just use the ratio. So let's erase this. So we use the ratio there. We say in this 200 jar, okay, 200 mils, we have this number of moles. Okay, what about if I have this volume now 20.7? How many moles am I going to have here? So X, and then from there, just cross multiply. So this will be 200x multiplied by this number multiplied by this, okay? So that will be 20.7 multiplied by 0.0499591. Okay, so to find x, we're just going to divide this side, okay, by 200, even this side by 200. So it means I'll just remain with x is equals to, and then I can punch this guy onto the calculator. Okay, so I have 20.7 multiplied by 0.04 995921. Okay, and then I'm dividing that by 200. Okay, so what do I get? I get 0.005170778 moles. Okay, so these moles here will be in this 20.7 mils. So I'll just write these moles on top here. So 0.005170778. Okay, so these are the moles that I have in here. So it means these are the moles that are going to react with the 10 moles of the what? The sodium hydroxide. Okay, so from there now, we can consider this reaction here, this equation here. Okay, we can consider this equation. We're first going to balance this chemical equation here. Okay, because you don't get the mole ratios unless things are what? Are balanced. Okay, so I don't want to erase these diagrams because I want you to guys to be seeing whatever is happening. So here, we can balance this thing. Okay, so here I have 2 sodium, so I can add a 2 there. Okay, it means the sodium is balanced. And then what else should I balance there? Okay, what else should I balance there? Okay, if I add the 2 here, it means the hydrogens on the left-hand side have become 4, but here I can only see 2. So I can also add the 2 there. Okay, so I have 4 hydrogens. Here I also have 2 plus 2, 4. The oxygens, I have 2 plus 4, 6. Even here I have 2 plus 4, 6. So everything is balanced now. Okay, so now from this chemical equation here, okay, since I've balanced it now, I can get the mole ratio of the sulfuric acid, okay, to the what? The sodium hydroxide. So you see that from the sodium hydroxide to the sulfuric acid, the ratio is what? 2 to 1. That's the mole ratio there. Okay, so if I have these moles, okay, for the sulfuric acid 0.0051 70778. Okay, how many moles of sodium hydroxide am I going to have? So we cross multiply, so it means X will just be equals to 2 multiplied by this number. Okay, so that will be 2 multiplied by the answer there. Okay, so I'm going to get what moles now. Okay, I'm going to get what moles of sodium hydroxide. Okay, so I'm getting 0.01, okay, 0.0341556 moles. And these moles here are now for the what? For the sodium hydroxide. Okay, I got the mole ratio between this and this. So now, since I have the moles of the sodium hydroxide, okay, I can get its molar mass by just getting the molar masses of these guys from the periodic table. Okay, so I have the molar mass and the moles. So I can use that now to come up with the what? To come up with the mass. Okay, so what is the molar mass of sodium hydroxide? Okay, so we add the molar mass of sodium plus the molar mass of um, oxygen plus the molar mass of what? Hydrogen. Okay, so what are we going to get approximately? Because this one is 23 point something, the sodium plus the oxygen 16 plus the hydrogen, which is 1.01. Okay, so when we add this, what do we get? Okay, so let me add it on my calculator. Okay, so the molar mass is approximately 40.01 grams per mole. Okay, so I have the moles and the molar mass. I can use them to find the mass of this what? Sodium hydroxide. So we're going to say, okay, I can even erase this now. We're going to say moles is equals to mass over molar mass, right? So I can make mass the subject. It's going to be equals to the moles times the molar mass. So what is the moles? The moles are 0.010341556 multiplied by the molar mass, which is 40.01. So if I multiply these, what do I get? Okay, so multiply by 0.01, 0.0341556. Okay, so when I do that, I'm getting okay, I'm getting approximately 0.413765655 grams of what? Sodium hydroxide. Okay, so I can even round off these to 3 significant figures. Okay, I'm going to have what? I'm going to have 0.41 0.414 grams. Okay, so that will be the mass of the sodium what? Hydroxide there. And we're done with question 1. All right, so thank you so much for watching this video. If you'd like to access the full solutions to the video, they are available on our website, okay? So on our website, we also have full video solutions to all the tutorial sheets that you've had so far and all the tutorial sheets that you have. So this was tutorial sheet 1. Okay, you can see we have the full video solutions on our website. This here is tutorial sheet 2. Okay, we have full video solutions on our website. You can watch and learn anytime. Tutorial sheet 3. Okay, we have full solutions on our website. These are the questions here from tutorial sheet 3. Tutorial sheet 4. You can see all these questions. We've solved them. The videos are there on our website. Tutorial sheet 5. Okay, we've solved all these questions and the videos are there on the website. So you can learn at any time at your own pace. We have explained all these videos in a very clear manner. Okay, so once you register and then you go on our website, you are going to see something like this. Okay, so this is our homepage on our website. So you just scroll down here, you're going to find the courses. So depending on the courses that you've enrolled for, you have enrolled there on the course if you've paid for it. Okay, so these this tutorial sheet, it was for chemistry. So if you want to access it, okay, as you are preparing for your test 1 exam or quizzes, okay, you just go on open course here for the chemistry. So you open the course, it's going to bring 2 folders. So there's general chemistry and bio and organic chemistry for those who are doing second semester at Apex. So since you're in first semester, okay, or if you're from any other university, you go in general chemistry. Okay, so in general chemistry, you're going to find about 5 folders. So here in the last folder, we have some lab report samples. So as you're going to do your labs, we have some samples here that you can check, and then you get to have an idea how to have to do the labs. Here we have the lessons and tutorials on each and every topic that you learn in the chemistry course. So if you open these lessons and tutorials, okay, you'll see that here you're going to have all the topics, okay, listed that you learn in chemistry. So introduction to chemistry, whatever you're going to learn, we've explained fully all the topics, okay? There are notes there and there are videos there you can watch at your own time, all the way to nuclear chemistry, if you're taking nuclear chemistry, okay? Once you leave this folder for the lessons and tutorials, you go back here. Okay, so once you're back here, you can see here we have handwritten summarized notes. So on all the topics, we have handwritten, well summarized notes if you want to read the handwritten notes. And they are very funny and they're very direct to the point. So you can also read them. Okay, if you want solutions to the assignments or tutorial sheets, you come to this folder here. Okay, so you open this folder for the assignments and tutorial sheet. Then depending on the university where you are at, okay, you'll find that folder. So this tutorial sheet were for the Apex people. Okay, so you can go to the Apex folder. Okay, and then you go to your intake. So in the January 2024 intakes, we also have full videos there. So you can even use them to learn. The concepts are the same. In 2024 July intake, you can learn still. In 2025 July, January intake, there are full videos there for all the tutorial sheets you can learn. So for you, who is 2025 July intake, you come to this folder. You're going to find all those videos on all those tutorial sheets. Okay, so you even use the videos for the past intakes, okay, because the concept are the same. So you can go in this folder, you learn all the tutorial sheets are solved here from tutorial sheet 1 all the way up to tutorial sheet 14 when you go to January 2025 here. If I open it, okay, and you go to the video solutions, we also have written solutions there, okay. You can see all these videos all the way from tutorial sheet 1, the assignment 1, the assignment 2, all the way to tutorial sheet 13, okay. So you can learn at your own time. Okay, it is a very good portal. And then here we also have written solutions. You can access them. So if you open here, you're going to find the written solutions. So this was for the January intake. So you can see all these written solutions. They are just waiting for you. Okay, so that's how you can access the tutorial sheets or the assignments. But if you'd like to access the past papers, okay, then it means you have to go to this folder here for the past papers. So you're going to find quiz papers. They are solved videos and there are also some written solutions. So you go to Apex. Okay, you also find videos on exam papers. So if I go to the videos there, you see that there are videos there for some exam papers, for some tests, for some quizzes. Okay, you can access all these and learn at your own time to prepare for your what? For your exams. Okay, so I hope you enjoyed the video. Thank you so much. If you'd like to register for our lessons, okay, just see the link in the description below. Okay, it has a link to our website. It has a link to the registration guide video. So you watch that video on how to register on our website, and then you can register and you can start learning at your own time. Okay, otherwise, thank you so much. This has been Tutor Solutions. For any questions, please reach out to me using the numbers in the description below.